Hey guys, what's up? Welcome back. Uh, Today we are gonna talk about complex data type in Python. We are gonna talk about complex data type in Python. Okay, complex data type. All right. So first of all, what is complex number? Okay, what is complex number? So any number of the form, any number of the form a plus bj is known as complex number, where a is real part and b is imaginary part. Okay, now we know what is complex number. Okay, here a plus bj, here um, a and b, here a and b can contain uh, integers, can contain integers or floating point values. Okay, so what I mean by saying that, let's take an example. For example, 3 plus 5j is valid. Okay, similarly 10 plus 6.5j is valid. Similarly 0.3 plus 0.3 plus 0.7j is also valid complex number. Okay, now what we have to keep in mind is that, first, what is the first point? First, in real part, if we use int value, then it can be either of, then it can be either of decimal, octal, binary, or hexadecimal. Okay, second, in imaginary part, we can only use in imaginary part if we use int values, then it can only be in decimal form. It can only be in decimal form. Okay, it can only be in decimal form. For example, let's take an example. Say a is equal to 0b 1 0 plus say 6j. It is valid. Okay, it is valid. Let's run. See, no error, so it is valid. Here in the uh, real part we are using integer value, and in that too we are using binary value. Okay, so it is valid. What if we use binary value in imaginary part 0b? Now let's run it. See, now we are getting the error here because we can only use the decimal form values. If we are using integral values, we can't use binary, octal or hexadecimal in imaginary part of complex values. Okay, so this is the simple rule which we have to keep in mind. Secondly, now how we can store the complex number in a variable. So for that, let's take an example. For example, 2 plus 7j. Let's run it. It is fine. Okay, let's take b is equal to 2.5 plus 7.5 j. Let's run it. It is valid. Let's take 2 plus 7.5 j. It is valid. Okay, don't forget this j. J is very important. With whichever entity you are using j, it is supposed to be imaginary number. What if we reverse the order? For example, d is equal to 7.5g plus 2. This time we are writing the imaginary part first and then the real part. Let's see. It is working fine. So order is not important. Okay, order of writing is not important. All right, understood? Okay, now we can perform some operations on complex type values. Okay, on complex type values. What are those? For example, a is equal to 1 plus 2j and b is equal to 1 plus 3j. Then if we add a plus b, then what should be the output? Output should be, according to the properties of complex number, output should be 2 plus 5j. Okay, so let's print it and see what will be the output if we print the value of c. Okay, it is coming the same. 2 plus 5j. So it we can add complex number. Okay. Similarly, if I want to subtract it, let's subtract it. Let's run now. What we'll get? We are getting minus 1j, because after subtracting we will definitely get minus 1j only. Okay. All right. Now suppose if we have some complex number, say 4 plus 5j, and I want to extract only real part of it, or I want to extract only imaginary part of it, then how can I do it? Okay, how can I do it? Okay, let's see. For example, a is equal to 4 plus 6.5j, and I want the real part. I want to store real part in one variable and imaginary part on another variable. So how we can do it? B is equal to, let's say in B, okay, let's say real part. Okay, real part. For real part, what we can do, we can use the property, say a real. Okay, if I write a dot real, then the real part of that variable will be stored in the variable. Okay, now imaginary part. Okay, let's store imaginary part, a dot imag. So in this, what value will be stored? 6.5j. And in this, what value will be stored? 4. Okay, let's try to print it. Okay, let's try to print it. See, you can see we are getting uh, real part as 4.0. Okay, 4.0. Actually, here whether we provide uh, integer value or float value, it takes it as a float value only. So that's why here 4.0 is coming. Okay, although we have provided only 4. Similarly, if I similarly the real part comes as 6.5. Okay, now let's see one more case. For example, a is equal to 4 plus 2j. Okay, 4 plus 2j. Let's copy it. Okay, so in real part there should be 4, in imaginary part there should be 2. Let's run it. Okay, here 4.0 and 2.0. Why? Because although we have provided only integral values, but it took it as a float value, that's why. Okay, and one thing also, if I want to check what is the type of a, if I want to check what is the type of a, is it really a complex data type, so we can check it by using type function, as I told you earlier. Type of a, let's run it. complex. So it is of complex type. Okay. So basically, uh, we use complex number in our scientific experiments or engineering for resolving certain kind of values, etc. Okay. So this is all about complex data type in Python. Thank you and have a nice day.